The discovery, the lost metal of Atlantis, Orichalcum. In 2015, marine archaeologists diving off the coast of Sicily stumbled upon a mystery that shouldn't exist. Resting just 10 feet beneath the waves near the ancient port of Gela lay the wreck of a Greek cargo ship. But scattered among the rotting timber were 39 heavy ingots that stopped the divers in their tracks. Despite being submerged for over 2,600 years, these bars didn't look old. They gleamed with a bizarre, golden red fire, completely immune to the corrosion that eats away at lesser metals. Initial field analysis proved they weren't gold, copper, or bronze. They were a sophisticated metallurgical blend with no known modern equivalent. The team had recovered what many believe to be the legendary metal of Atlantis, Orichalcum. The myth becomes real. According to Plato's Critias, Orichalcum was second in value only to gold, used to plate the inner sanctums of Atlantis and the Temple of Poseidon itself. For centuries, historians dismissed this as a myth until those 39 ingots surfaced. Laboratory tests revealed a shocking complexity, a precise fusion of copper, zinc, nickel, lead, and trace amounts of rare earth metals. But the puzzle wasn't just the ingredients, it was the process. The metal displayed a unique spectral fingerprint and density that defies historical timelines. The internal microstructure suggested an unusually slow cooling process and chemical reactions achieved under tightly controlled heat technology that was supposedly impossible for 6th century BCE furnaces. Furthermore, the raw materials were sourced from locations scattered across the Mediterranean and sub-Saharan Africa, implying a global supply chain centuries ahead of its time. The suppression. How could a civilization predating the Roman Empire mass-produce a superalloy we still can't perfectly duplicate? We may never know, because the research went dark. Shortly after the findings went public, the Italian Ministry of Culture quietly restricted access to the shipwreck. Independent researchers were denied samples, and the ingots were moved to a secure state facility. Updates on the analysis ceased immediately. Stranger still, a lead metallurgy expert from the original team abruptly resigned from his university post, and his digital publications on the subject were scrubbed from the internet. The dangerous property rumors began to circulate that Orichalcum's rediscovery threatened the established timeline of human history, or worse, that the alloy possessed industrial properties the government wanted to keep hidden. Why is this metal so dangerous? It isn't just about durability. Early electromagnetic tests revealed irregular resistance patterns, hinting that Orichalcum acts as a high-performance signal shield or an advanced energy conductor. These are properties that modern aerospace and military industries would kill to possess. The modern leak. Is this why the testing stopped? Because Orichalcum isn't a relic, but a technology? In 2021, a leaked report from a major defense contractor surfaced, mentioning experimental alloys being benchmarked against historical samples of uncertain origin, specifically one labeled OCLA. When pressed for comment, the contractor stayed silent, and the document vanished following a swift copyright claim. No further mentions of Orichalcum have appeared in mainstream science journals since. If the Gela ingots truly represent a forgotten science, one capable of resisting time, salt water, and electromagnetic interference, then the boundaries of ancient knowledge are far wider than we are allowed to believe. And someone is making sure it stays that way. The blade that breaks physics. The mystery of Damascus Steel. The impossible artifact. In 1837, deep in the Hyderabad region of India, a Scottish officer named James Wilkinson witnessed something that defied the laws of metallurgy. He had acquired a curved sword from a local nobleman, a weapon that looked less like steel and more like liquid smoke, trapped in a solid form. The blade was terrifyingly effective. Reports from the time claim it could slice through a British rifle barrel without chipping its edge, yet it was flexible enough to bend nearly 90 degrees and snap back perfectly straight. Baffled, Wilkinson sent the weapon to London. Victorian metallurgists were astounded. They had never seen steel with such a paradoxical combination of hardness and flexibility. They held in their hands an authentic artifact of Damascus steel, a technology that remains one of history's greatest unsolved puzzles. The origin of Wootz, historically known as Wootz, this steel originated in southern India before spreading to the Middle East by the 3rd century CE. By the time of the Crusades, these blades were the stuff of nightmares for European knights. Their signature was the damask pattern, intricate, flowing, water-like bands etched into the metal. But this wasn't just decoration. It was the result of a microscopic structure that modern science is only beginning to understand. The patterns were created by bands of iron carbide particles, giving the steel a serrated edge at a microscopic level, like a saw blade made of diamond-hard teeth. Ancient nanotechnology. Here is where the story gets strange. In 2006, a team of researchers at the University of Dresden dissolved a piece of authentic Damascus steel in acid. Under the electron microscope, they didn't just find steel, they found carbon nanotubes. These are cylindrical carbon molecules with tensile strength stronger than diamond, a material we only discovered in the late 20th century. Somehow, ancient smiths in India, using clay furnaces and plant fibers, were manufacturing nanotechnology 1,000 years ago. They achieved this by smelting iron ore with specific plant materials in sealed crucibles, a low oxygen environment that allowed for precise carbon absorption. The process relied on a specific rhythm of heating and cooling that remains unknown. The slightest deviation in temperature or humidity would ruin the batch. The lost recipe. So, why can't we make it today? Despite lasers, supercomputers, and advanced alloys, modern metallurgy cannot consistently replicate the internal lattice of true Damascus steel. We can mimic the look through acid etching or pattern welding, but the mechanical soul of the metal is missing. Some scholars believe the secret lay in the raw earth itself. The ores used in ancient India likely contained trace amounts of vanadium and molybdenum impurities that acted as the catalyst for these nanotube structures. Those specific mines were depleted by the 18th century, and with them, the chemical key was lost. The silencing. However, others argue the loss wasn't accidental. As the British Raj expanded, colonial powers actively suppressed indigenous industries. The British Arms Act and the dismantling of local mining guilds effectively severed the oral traditions of the mastersmiths. The knowledge didn't just fade, it was erased. This raises a massive what if. If we could revive the true process of forging steel with embedded nanotubes at ambient temperatures, it would revolutionize everything from aerospace engineering to surgical tools. It would render many modern factories obsolete. The final anomaly is that why funding for Wootz revival projects is virtually non-existent. In 2019, a private museum in Istanbul allowed a Damascus blade to be scanned with magnetic resonance imaging, MRI. The results were unsettling. The scan revealed anomalies in the metal's internal magnetic field, forming organized spirals never seen in any known modern alloy. No explanation was offered. The museum has since restricted access to the artifact, citing preservation concerns. If Damascus steel truly embodies a lost science of molecular engineering, its disappearance might be the greatest intellectual theft in history. In 1980, beneath the shimmering blue waves off the coast of Baiae, Italy, a team of marine archaeologists discovered something that shouldn't exist. They were scanning the skeletal ruins of an ancient harbor when they found it. A massive, monolithic breakwater wall, submerged under 30 feet of salt water. By all laws of modern engineering, this wall should have been dust. Modern marine concrete is a ticking time bomb. It corrodes, cracks, and crumbles within decades of hitting salt water. But this Roman structure, it wasn't just surviving, it was thriving. After 2,000 years of relentless battering by the Mediterranean Sea, it was pristine. Its seams were sealed tight, and its core had hardened into a stone far denser than the day it was poured. The Romans knew a secret, and it was buried deep within the ruins of the empire. The impossible chemistry. What baffled scientists wasn't just that the wall lasted, it was how. They discovered a chemical paradox that defies modern logic. Roman concrete actually gets stronger the older it gets. Think about our modern skyline. We rely on Portland cement, a material that is responsible for a massive 8% of global CO2 emissions, yet it begins to degrade the moment it sets. The Romans? They used a different recipe, a volcanic ash called pozzolana, mixed with lime and seawater. When these ingredients mix, they trigger a rare chemical reaction, birthing a mineral called aluminous tobermorite. Here is the magic. As seawater seeps into the concrete over centuries, it doesn't rot the structure. Instead, it feeds it. The saltwater causes these crystals to grow and interlock, knitting the concrete back together and reinforcing it from the inside out. While modern bridges rust and crumble, Roman concrete heals itself. The failed replication. By the early 2000s, the race was on. Elite laboratories scrambled to reverse engineer this immortal stone. A landmark 2017 study finally cracked the code, confirming that the durability came from the specific interaction between volcanic material and the sea. But here is where the science hit a wall. Every attempt to mass produce this material failed. The specific ash the Romans used came from unique volcanic vents near the Bay of Naples, a geochemical fingerprint that is nearly impossible to synthesize cheaply. Moreover, the Romans played the long game. Their concrete required slow curing and underwater setting that defies the fast cash, rapid build economics of the 21st century. The conspiracy, and then the lights went out. Just as the potential of this technology became clear, the research went dark. As news of these findings surfaced, studies were abruptly halted. Massive industrial concrete conglomerates, the giants of modern infrastructure, quietly distanced themselves from the research. In a move that shocked the scientific community, a lead investigator at a U.S. Department of Energy lab was reassigned right before publishing his full results. Joint research agreements with European institutes vanished from public databases as if they never existed. Whistleblowers have since come forward claiming that funding to revive these ancient methods was explicitly denied. The reason given? It was non-commercially viable and disruptive to existing markets. The Truman Show reality, the implications are terrifying. If we built dams, bridges, and seawalls with Roman concrete, they could last for millennia, saving trillions in tax dollars and preventing ecological disasters. So you have to ask, is our world being kept deliberately fragile? Why abandon a superior, self-healing material for one that guarantees expensive repairs every 40 years? Who benefits when a bridge falls down? In 2022, satellite mapping over ancient Ostia revealed dozens more of these invincible structures hiding under the seafloor, but you can't go see them. These sites have been declared marine hazard protection zones, off limits to the public. If these relics are truly stronger than steel and untouched by time, then the very foundation of our modern construction industry isn't built on concrete. It's built on lies. In 1850, deep within the dust of the ancient Assyrian city of Nimrud in what is now northern Iraq, British archaeologist Austin Henry Layard unearthed an object that shouldn't exist. Buried inside a palace complex, he found a small, oval piece of rock crystal. It was perfectly smooth, convex, and possessed an uncanny clarity. At first, it was dismissed as a simple piece of jewelry, a decorative bauble, but further study revealed a shocking truth. This wasn't just a rock. It had been ground and polished to optical precision. Layard had unknowingly rediscovered what is now called the Nimrud lens, potentially the oldest optical device ever found. Dated to approximately 750 BCE, this 3,000-year-old artifact is carved from natural quartz. It measures about 1.5 inches in diameter and produces a near-perfect 3x magnification. But here is the kicker. It exhibits an intentional biconvex shape. This requires not just craftsmanship, but a mathematical understanding of how light behaves when refracted knowledge that history says didn't exist for another 1,000 years. And this wasn't a one-off. Since the Nimrud discovery, similar polished crystals have surfaced across Sumerian and Babylonian sites. Museums often label them as ritual objects, or buttons, but in 2007, researchers at the University of Geneva re-examined a collection of these lenses using laser interferometry. The results? Several match the precise curvature needed for controlled focal lengths. This raises a massive question. How did a civilization nearly 3,000 years ago achieve optical engineering we associate with the Renaissance? Conventional history claims the telescope wasn't invented until the 17th century, yet cuneiform tablets from the exact same era as the Nimrud lens contain star charts of baffling accuracy. They depict planetary motions and stellar anomalies that are arguably invisible to the naked eye. Could Assyrian astronomers have used these lenses to scan the heavens? If so, they beat Galileo by 2 millennia. Despite these game-changing implications, most of these lenses remain locked away in dusty museum vaults, misclassified as decorative. Requests to reclassify them as scientific instruments are repeatedly denied. In 2012, a visiting optics expert from a German institute attempted to scan a collection of Mesopotamian crystals at the British Museum. After he raised questions about their magnification properties, he was suddenly barred from the collection. The official reason? Preservation concerns. Yet, no such restrictions existed for other quartz artifacts in the same room. What were they really used for? Microscopic engraving, surgery, or something more advanced? Some radical theories even suggest they were components of a larger optical device, perhaps a communication system that focused light over long distances, like a primitive laser. Mainstream academia laughs this off, yet they have never experimentally disproven it. Stranger still, satellite imagery of desert dig sites in modern Iraq reveals patterns of stone alignments that resemble massive optical arrays, but good luck checking them out. These areas have been declared restricted zones by military authorities, officially cited as heritage protection. No public research has occurred there in over a decade. If the Nimrud lens represents a suppressed chapter in human history, then our timeline of discovery isn't a straight line, it's a cycle. Knowledge isn't just gained, it is lost, forgotten, and sometimes quietly buried under the sand.